Hello guys. Welcome to a new episode in our LabView tutorials, and we're doing the Sudoku solver. And now we're moving on to our next step of the code, in which case what we've done so far is we've taken the data, we've compiled it, and then we've broken it up apart into its rows, columns, and sections, and the element. We set up a system that lets us check one by one whatever we want. And we set up what I'm calling for now a possibility array. So basically, at any point, we will know what could be there by looking at the cross sections across. Our model is supposed to be this one right here, right? Which is going to be number x3 and y0, where the possibility here can, it says nothing. This should be an impossible scenario to reach, by the way. An empty array should be impossible. And that's because there's a 4 right there. So I'm going to set that to 0. There we go. What? Is there another 4? Oh, there's another 4 right there. There we go. Now let's run it. There we go. So now this one can be a 4. Now remember, we're using random numbers that do not follow the rules of Sudoku. So whatever we have here is very, very wrong rules. But in this specific point, we have them pretty correct to give us the number 4. So what do we need to do with this number 4? Well, what we're going to have to do is we're going to have to take this 4 and put it back into the system here to get the output. So what I'm going to do is I'm going to take this output, which is our initial output, and then I'm going to add a second one, which I'm going to call our second output. Oh, where is it? There it is. And I'm going to put this right next to this one. And we'll move the view a little. There we go. So there we go. So this is the before, and this is the before, that's the after. Then hopefully this will help us to work with these numbers. So what I want to do now is I want to take this 4, since it is a 4, and put it into this system right here, the output. And how do we do that? Well, we're going to take the array. First thing we're going to do is we're going to make sure there's only one number here. And to do that, we can easily do it with the array size. So I take the size of this array, right? The size of this. Now the size of this, in this case, and let's do a testing indicator, should be 1. Ta-da, it is 1. Perfect. So if it is 1, we come here and we're going to do an equal to. Do they have equal to 1? No, they do not have equal to 1. So we're going to have to do it ourselves. So if this is equal to, create a constant, 1, right? What happens if this is equal to 1? Well, we're going to have to create a selection system, which is going to tell us what happens if this is equal to 1. If this is equal to 1, we can do this in a true-false case, in a case structure. Like here, we can use this case structure, square, or we can use this selector. Now the difference is that the selector, both true and false cases will be processed, yet only the true or false case will output. In this block, for example, if it's false, everything here will not process. It will only process if it is true. In the false case, this is what processes. This does not process. Yet with the selector, this will. Now, in this case, this is a really small step that I don't really care about. So if it wants to process it, that's fine. For better and faster and smoother coding, using a second true or false case structure in here would be just a little more efficient, because then this will not need to process every single time. And that's processing 81 times. In theory, because this is processing once. Oh, I'm sorry, not 81, 36 times. 24 times, because this is going to process for these 9, and these 9, right? So keep that in mind. All right, 27 times. Wow. Okay, sorry. So if the size is only 1, right? I'm gonna do it in a true-false system right now, and then later on we'll convert it into case structures if need be. But I'm not too worried about processing speed at the moment. So if this is equal to 1, what I'm gonna need to do is I'm gonna need to take this array and I'm gonna need to index that first single point out of it, right? And we did this previously, and what I'm gonna do is I'm gonna index out of this the there we go. Create constant the 0th point, which is going to be a number, and I want this number to go through. Actually, no, I don't want the number to go through, but we'll get back to that. So I'm going to bring to the false case, if this is not 1, I'm going to go back, the output array that we have a million years ago, that's what we're going to have to use. So I want this to come down through here, be the false case. That's going to be the secondary output, unless we do a change. Now, if this is true, we're going to have to do a replace. And what are we replacing? We are replacing into this array right here. Right? That's the same. Okay, I can put it here. That's the array that comes down to here. What we're doing here, if you look at this, is I tell it where and I tell it what. But I'm going to have to tell it 2 wheres, the row and the column, which are all the way back here, the row and the column. Now, there's a small trick we could use to access this data, but I'm not going to use it at this point because, well, I don't want to complicate things more, and later on we're not going to have this option. So the X, which is our column, which goes here as the column setting, the second one. And this one here is going to be our row setting. And there it is. Here's our row, here's our column. This is the point that we're looking into. And what we're going to put there is the new number, in this case a 4. And this number will go into here and go out as output. So hopefully this will kind of make sense. Let's go back here. Now when I run this, what should happen is this should become a 4. So watch out for this. If it doesn't become a 4, I did something wrong. There it is. Now it's a 4. It was not a 4, and now it is 4. The computer has ran through the code. It has found that in this column, the top column, this should be a 4. Now, ideally, we want the computer to go through every single point and do this. And this is where we're going to get into our next complex phase in this. And here's what we're going to do. First, what I'm going to do is I'm going to convert this from this case to the true-false case in the case structure. So basically we want all the same things to happen, right? So I'm going to put them all in here, and then we'll see what. So the true or false selector, same one. In the true case, right, we want this to occur. So what happened here, I'm going to move this down for now, is we took this array, we took this row, there it is, we took this column, here we took this number data, which I can actually move into it. Everything I move into this is good because it simplifies processing, right? Because now this does not need to process unless there is a true case. So that's just maybe a fraction faster processing, but still it's a bit faster, so why not do it? And there we go. That is everything. The output from here will be this new output right there, right? The only thing is, in the false case, what happens is this goes straight through, right, with no editing at all. So there it is. Here's our true false cage, if you want to call it that. We don't need this, we don't need this, we don't need this, we don't need this. right? So all these wires here we do not need. There is a quick button that cleans up dead wires that I need to look up again. I seem to have forgotten it. So there we go. What is this? Oh, that's our possibility array, and this is our output array right there. These are the possibilities. This here is what will test whether this is true or false. And there it is. And there's this line. Simplify it even more. There we go. And there we go. Much simpler. This is much simpler right now to look at, and it outputs the data. I could bring this from here and put it there, but I'll do that later on. I'm hoping this is not being too complicated and you guys are still able to follow up with what's going on. The next thing I want to do is simplify this even more. And to do that, sadly, I'm going to have to get rid of all these. So I hope you guys understand what these are doing. We do not need them anymore, right? So we don't need this. We know it works. So by knowing it works, I don't need it. We know this works. We know this works. We know this works. So we don't need any of these. We know this works. What is that? That's the element. We know this works. We're going to need this for later, so I'm going to leave that. So now what I'm going to do is I'm going to go about simplifying this code further for, I don't want to say for fun, but for further simplicity. You will see that when I do this, I'm going to maximize this, that when I do this, the overall space that this code is taking will become nothing. It will become very, very small. And that actually opens up the gates for even further simplifications. So yeah, there we go. So for example, right now I just simplified this 0. I found a 0 here and a 0 here, and instead of having 2 zeros, now there's only 1. And we can probably further combine things. So these 9s could combine with each other. So we only need 1 of these 9s now. These 1s can combine with each other. So we only need 1. These simplifications are completely, it does not matter, right? It does not matter at all. Yeah, I'm just doing them because you can say I trained myself to do this and I'm just stuck doing it every single time I run into this case of this kind of a system. I just do this. So if you guys get into it, that's great. I find it to be excellent space saving. And in this case, we are not using sub-VIs, which is something that is very essential to good programming in LabView. And I'll get into that and more of that later on as we move along with the lectures or tutorials or whatever you guys want to call this. There we go. I can actually put the 9 at the bottom, save a little more space. Yeah, see, I just try to save space wherever I can. There we go, that's fine for now. So we have, when I triple click, these are all the rows. Ah, there's these. Alright, let's start fixing up these wires. So here's 1, here's 2, here's 3 and 4. Then we can take this, move it all the way. Oh. Then we can move this up. Let's see. There was this one right there, which could connect to this one right here. So let's move these a step back. Let's get all these ones to connect to each other. One family. There it is. All the ones are connected. This 0 seems to be taking up more space than it should. And to fix that, I'm going to move it here, connect it backwards through the equal sign. So there we go. It's connected backwards through the equal sign. We can actually move this a little higher so that this line is straight. And then we can move this a little here, move this a little down. Yeah, again, I'm sorry guys. I know, I really know how boring this is. Many people that have tried to watch me work on LabView have complained about this, and I don't know, I have to do it this way, and I'm sorry. That's all I can say is I'm sorry. So there we go. Let's just get this line here. I'm gonna move this up here and move this to the outside. There it is. So there we go. This has been further simplified. There's probably some simplifications that we can still do, but I will not work on those now. Yeah, so I will not be working on those now. This here is using a lot of, this is using all the data from here and just one line from there. And this line is from all the way over here. So we can actually move this entire setup into this space down here to save even more space. So let's work on that. There we go. Oh, connect there. There we go. Move this backwards. This wire, I'm going to triple click it. As you can see, it's coming all the way from here. So we can probably get it to directly just spurt out from between these two and give us the data we need. Or we can do even one better. We can move all this downwards, and we can move all the X, Y, and Z data through here. So here's this one, here's that one. And this needs to be on top, this needs to be on the bottom, and then this wire could come through from here. There we go. Now let's get some alignment. There we go. Let's move this up. There we go. And let's move this up. There it is. So there we go. That leaves this line, which is the input line from this true or false case. And let's move that. Now I'm going to leave this on the right end of this for now. It's one of those things that does not matter too much, and this wire can actually be a little simpler now. There we go. There we go. And this needs data. There it is. So there we go. Here is everything that we have done so far in a small little cute bundle right there. Right, you see it? This is the original output, is right here, and this should actually just sit right there with our original output. There we go. So as you remember, this block does absolutely nothing almost. This here does nothing. These here are the selectors that we have set up select the rows. This is our code right here. That's it. That's the entire code is right there. And we can have it actually enter from right down here. There it is. Here's our code. Here's our entire code. Now all we need to do is set this code to run. Let's go to the other screen. To run for all this, right? It's for every single point here. So we're going to have to do this 9 times for the x's, 9 times for the y's. Very, I don't want to call this simple, but it's not that complicated. Now, we could do further simplifications, but I will not do them for now. For now, I'm going to add our for loops. Here's our first for loop. I'm going to convert this into a shift register. I'm going to get rid of everything here and we'll reconnect them. And we're going to have to do this 2 times. We're going to have to do this once for the x's, once for the y's. So again, this should be a shift register. This will connect to this, which will connect to this, which will connect to that. So what do these ends do? So how many times do we want to run them? Well, we know that this is 9 times, right? We're going to run each one 9 times, 1 for the x's, 1 for the y's. Now, which ones do you want the x's to be and which ones do you want the y's to be? Does not matter. Here, this I will be our x's if you want, and this I will be our y's. Again, does not really matter. So as long as we're doing 9 of each. So this is going to be, if you want, the columns. And then instead of this, we shall connect this one. We have eliminated our controls because, well, we frankly don't need the controls in the first place, right? The whole point of this is to get the computer to solve it for us. So there we go. This is the steps that we took. So what did I just do? In a very simple format, what I did is I set up a system right now in front of you that will take the setup we have, this setup, and it will run it for every single point of our system. Let's go back to the system here. So it will do it for this point, then this point, then this point, then this point, and this point, and it will replace the points that have only 1. How cool is that? How easy is that for our system to do, right? Very easy. And I'm going to make this the exact size, again, just for simplification and because I know there's a lot of people that complain that the code becomes too crazy and complicated, but I wanted to show you guys that it does not have to be that way, right? It totally does not have to be that way. Our entire code is so small right now. It was bigger to develop, obviously, but now it's this small, and there it is. This is the entire code right there. How awesome is this? There's our code right here, this block. Now this will run only once, right? We want it to run many times. So we're going to put this system either in a for loop and tell it, okay, run 10 times, 20 times, 1,000 times, or in a while loop. A while loop will keep running until it solves the problem. For our purposes right now, I'm going to throw it into a for loop so that I can tell it exactly how many times I want it to run. And there we go. Go through here, come back out here, show me the output of all your times. And how many times do you want to run it? I'm going to put a control for that. There it is. So let's say run this 10 times. Let's see what happens after it runs 10 times. There it is. Oh. Whoa. This is very bad. I'm getting zeros. What if I run it once? I get a 1. How did I get a 1 here? This is very odd. I broke it. Did I break it? Let's see. So what happened here? This is running 9 times within 9 times, right? And each time it's going to take a different point and it's going to study that point, and it's going to do whatever we have discussed. Now, in what we have discussed, there's no... okay, I know what the mistake is. So, since this is a fake Sudoku, the problem is that this here, the size, can be 0, right? So basically what we need to do here is to check if it's equal to 1 and if it's equal to 0, but we'll need to take out that functionality later on, right? So keep in mind, this functionality that I'm about to add needs to be removed later on, right? So if, let's see, comparison equal to 0, if this is equal to 1, if this is equal to 0, and what we need is a, let's see, we're gonna go to Boolean, we're gonna invert it, not this, or we could have said, okay, yeah, we could have said if this is not 0, right? Okay, let's think about this. If this is 1, that means there's only one number in there, it's true. In all other cases, I want it to be false. So if this is equal to 0, I want this to run as false, not as true. So, so if this is 0, this is definitely false. So if this is 0, which is true, and this is false, I need to take the... Okay, why am I complicating this? I'm sorry, guys. I'm just gonna do a selector for now, and we shouldn't encounter this problem in the real thing. So if this is 0, what do? We send this signal or the opposite of this signal. That's what we're gonna be doing. Or we're gonna send the not of this signal. Sorry, this looks a little messy. This shouldn't be here. It's just because the game is wrong, we need to put this to fix it. So when this is 0, which is true, we send in this one, which is 1, which is going to be false. Now, in all other cases, this is false. Huh? I just confused myself. Okay, if this is 0, we want this to be false, which is what's going to come out of here. If this is 1, if this is 0, okay. I don't want to confuse myself any further, so I'm going to go back here and I'm going to set up the TrueFalse here before it goes out. So if this is 0, true, I want it to take in, just send out the same signal, otherwise send out the new signal. There, hopefully this will fix it. Let's run it. Nope, that didn't fix it. So this is where the complex and fun world of debugging starts. So we're running this 9 times, right? So we're running this from 0 to 8, here and here. So this runs 8 times, this runs 8 times. And then each time it's self-updating. That's what these are doing. These are self-updating the system with the new answer. So for every single point, it will do this. This will update the system, which will create a new answer here based on the new input. And then that will be translated and processed. Okay, so let's change this to, if it is equal to, if it's less than or equal to 0. Maybe it's giving me a negative answer. Right? Let's give that a shot. Huh, still wrong. Alright, so this is like an excellent point to see how we can debug our system. There's definitely something very small that is wrong that's going on. I'm gonna run these only once to try to detect what would happen. There we go. All the numbers are there except the number 1 has now been converted into a 0. And we need to figure out why. Because this one should stay a 1. There should be no reason ever why this number becomes a 0. That is the problem. You know what the problem was. I'm sorry, I know I've said that before. But here's a new idea. I'm going to call this an idea. Here's a new idea as to what the problem is in this example. What I believe the problem is. The problem is not where I thought it was. The problem is actually up here in our false statement. So in our false statement, it's sending in a number which is a single 0, right? And what's happening is the program is looking at this single 0 and is thinking that it is a 1. And it's converting this number into a 0 because of it. So all I need to do is just increase the size of this array, and we should be fine. There we go. This should do it. Cross your finger. Okay, let's run it on the number 1. There it is. Yeah, let's go back to our 9 system. Let's run it. Okay, we're getting answers now. So, did you guys see what just happened? This went from... Okay, can we do this as 0? Yeah, there we go. So here's what it is. Now notice that this is going to become a 4 and this is going to become an 8. When I do this only once, there it is. Oh, this became an 8 too. Now, if I run this 10 times, I might find more answers. It will take a little longer, but it would find more and more answers, but not all of them. As you can see, we still have a lot of zeros here. But there has been change from here to here. Between this and that, there has been change. I'm going to go ahead and try something, which I'm not sure if it will work, but I'm going to try to subtract the original from the new one and see if we get an array with the individual numbers subtracted. If this works, that would be pretty cool, because what that means is we can see the change that was made. There it is. You see the change was this became -4, this became -8, this became 8. There was only 3 changes done to this one. Now, if we were doing a real Sudoku, this might be easier. Let's go ahead and do that. Let's do a test. So let's do a easy Sudoku. Then let's go to images. And how about we do this one or this one? This one does not seem to work, but let's do this one. So first, first I'm gonna minimize this. There, keep that there. First I'm gonna convert all these to zeros. Oh. We should set up a reset button to make this easier. And perhaps as we're moving along, what we can do is we can set up a system that will auto-detect the numbers from an image. How awesome would that be? That could be the next project that we work on. I just want to see. Now, I need to tell you guys that the system will not, and I repeat, will not solve the entire Sudoku. So keep that in mind, guys. This will not solve everything, because a Sudoku puzzle has other tricks that we need to implement. But for now, it's fine. 6, 3, 5, 7, 4, and then what do we have? We have a 3, a 9, a 6, 8. What is that? That's a 4, 3, 7, 9, 7, 1, 3. This is a 6. This is a 2. This is a 5. This is a 1. This is a 2. This is a 3. This is an 8. And this is a 4. Then here we have a 3, we have a 6, we have a 1, we have a 2, we have a 4, 6, 9, 1, 2, 8, 5, 5, and a 3. There we go. So let's see if our system can solve this Sudoku. I'm going to run it for 100 times just to get more and more results. This might take a little longer to do, but that's fine. Let's see how much of this puzzle it will solve. There we go. So this is the puzzle, as we put it in, and this here is the change, right? This is the completed one. I believe, oh my god, look at that. It completed the entire Sudoku puzzle. Do you guys see that? 2613758. I don't see any zeros in here. This little code that we did just completed this Sudoku puzzle. Let's see, is there an online Sudoku solver? There we go. Let's go ahead and see if we got the right answer, which I'm pretty sure. Okay, let's see, 0. What is that? Oh wait, no, this is a 300804. Then this was 9 0 0 0 0 4 0 0 0 6 0 3. Oh no no no. You were 3. You were 7. You were 9 5 1 2. Oh, what? It's because it jumps automatically. 3 8 0. Okay. These are all zeros. That's going to be 7 1 3 6 2 space space 4 space 3 space 6 4 space 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 1 space 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 6 0 5 2 3 1 space 2 0 0 9 0 8 0. There we go. Solve partially, blah blah blah. How about this one? Solve. I've never used this before. There it is. Let's see. So 2 6 1 3 7 5 8 9 4 5 3 7 8 9 4 1 6 2 9 4 8 2 1 6 3 5 7 6 9 4 7 5 1. Next line 8 2 5 9 4 3 6 7 1. Let's see. Last line 1 7 2 5 3. So it looks like it solved it. So there we go. Let's take this. Bring this up. Here it is, our little code. I need to remind you guys, this is the code right here. This right here. I'm going to put it into an empty flat sequence just to show you. This is the code. Whatever's in this box is the code. Everything out here is just trash, right? So that is the code that we just did right here. And this code solves a Sudoku, a super easy Sudoku. Again, as I said, this will not always work. This only worked this time because I chose a super easy one. The harder ones require more advanced kinds of logic that we need to implement, but we're not going to do that now. We'll leave that for later. I just wanted to show you guys a simple program that you can do with LabView that would do this. So I think this is pretty awesome. There we go. Here's the user interface. As I said, this is what a person would see. We input our data right here. It shows us this is the pre and this is the post after calculation. This is the difference. Well, we use that only once, but it's fine. So there we go. From code to an actual program that does something. We can add to it, but we can do that later on. So there we go. Thank you guys for watching. This is an easy Sudoku solver. That solves only easy puzzles, so that's very important to point out. I just want to do one thing at this point. I'm going to go ahead and save this, and then I'm going to get rid of these useless parts that we don't actually need. Right, there we go, and Control E, let me show it. There we go. So this is just the parts that I actually care about. It's basically input and that, and I wanted to show you this cleanup, and I'm curious how it is going to make this better. So let's see. So that's how it would do it, which I don't like at all. I like my way much better, because if you look here, like, there's too much complication in the lines, but it does not matter as long as it works, right? And mine looks much simpler and smaller. So whatever. All right, guys. So thank you for watching, and I will see you guys in our next episode. I will take, okay, so the people from my group, if you guys will comment with all the questions, whatever you don't understand, and in my next episode I will go ahead and expand and explain everything that I've done here that you guys may not understand. For example, I can focus on case structures, I can focus on how these for loops work, what these tunneling systems are. I'll probably work on doing those in our next episode. Alright guys, thank you for watching, and I hope you like this project, and you guys can try it yourself and send it to me, or I can help you maybe, or comment or ask me questions. Alright guys, I will see you guys next time. I hope you had fun. Bye guys.